Eric Sammer is the founder and CEO of Decodable and has been one of the really leading lights of event streaming tech in the last decade. I was delighted to have him on the show today. We're talking about event streaming, streaming databases, terminal databases, kind of how, again, exploring this theme of how we query streams through Eric's eyes. Let's listen in. Hello and welcome to another episode of the Realtime Analytics Podcast. I am your host, Tim Berglund, and I'm joined in the studio today by Eric Sammer.
That is entirely true. Thanks for having me.
It actually is. Eric, welcome to the show. And Eric, if you don't know him, he is the founder and CEO of a company called Decodable. And Eric, for people, in case anybody doesn't know, give us a little bit of how'd you get to where you are?
Yeah, I mean, so Decodable is a stream processing platform. And really what we do is, it's not wildly complicated. We connect to source systems, we process data in real time, and then we connect to sync systems, including things like Apache Pinot and StarTree, for which we love.
Well, thank you.
We love.
Yes.
To process data and make it available for whatever the use case is. And that can be as simple as cleansing and transformation and masking PII data, in the cases of systems like StarTree and Pinot, where that data is being served back out to some application in real time or user-facing analytics, all the use cases that I'm sure you could probably describe better than I could. But also things like powering data warehouses for offline analytics and model serving and those kinds of things, or even just feeding that data back into other Kafka topics that are powering like microservices and those kinds of things. That's kind of Decodable in a nutshell.
Yeah, so integration and real-time compute, streaming compute.
That's right.
Yeah.
That's right. So both SQL and these days we also support kind of what we call custom pipelines. So basically like the Flink API. So you can build, you can take a pre-existing Apache Flink job and kind of drop it into Decodable and get like all the Decodable magic, nice. All the sort of hosted, managed stuff that we do around Apache Flink and Debezium and those kinds of things.
Yeah. Love it. In the Pinot case, and we'll sort of get to Pinot. That's not necessarily what today's conversation is about. But in that case, it's, I guess, not unusual that you don't just have the topic lying around with all of the fields in it magically. This is what I would like my table to look like. Oh, look, I'll just ingest that. So doing that streaming, enrichment, or join prior to ingest is even that is a fairly simple thing to do. But
Right. Nobody watching this show, but some people don't have the cleanest data in the world.
Certainly. That's not our subscribers. But
right.
Then there are those others.
Right.
Yeah.
So none of you, but some people are taking data from like various, let's call them legacy systems, loving systems,
Yes.
things that we care about, critical data. Jokes aside, it's everything from like, ERP systems and like CRM systems, and then joining that with like user behavior data or something like that, or clickstream and event data, or ad serve, ad event, ad
truly
impressions.
evented things with legacy sort of entity data.
Right.
Yeah.
Right. And then, getting that sort of structured the right way. And especially if that data is coming from multiple systems, sort of normalizing that, even the field names, and sort of making it optimized for the least amount of what I would call useless processing at serving time. So like there's certain processing you need to do at serving time, or sort of like presentation application time, things like aggregations and sort of, filters and projections and those kinds of things. But I think what you don't want to be doing is like crazy regex, to like parse out sort of different elements or rename fields and all these other kinds of things to serve that data in real time.
At serving time.
Right, at serving time.
Yeah, you'd rather not.
If the thing that you care about is latency and query concurrency, right? So like the question here is like, can we cook that data in the way that is most amenable to the end application? Like, at least in the case of something like Pinot and StarTree.
Right.
Does that make sense?
It really does. And this is kind of, we're going there. This is kind of what I wanted to talk to you about. This is your this is Eric's first appearance on the Real-Time Analytics podcast. I really don't think you're last. I think this is going to be a thing that we just do.
I appreciate that.
Of course. So I've been exploring this theme on the podcast recently. I'm calling it how to query a stream. And I think there's an interesting perspective. I just kind of want to, I want to get at the way you peel that onion and the way you think about that. But the thing you just said about cooking the data to make it most amenable to that low latency, high concurrency querying, like you do with Pinot, if Pinot is the terminal state or terminal location for the data, that's a good idea. Yet there is still a slider that you set there, right? Because the old way of doing it before, say, there was a Pinot or anything like it, if you had to do this, you had, and we were talking before the show, we were talking about the serving layer. You said something about serving. And where my mind goes, and this is a little bit, I think, unfair, but I think, oh, you mean the key value store in which you put your pre-computed aggregates. And so there's that side of the continuum where you've really you've cooked it and it's plated and there's a little drizzle of balsamic and a puff of palm puree on the side. It's like, you did a thing, which is hard to do. And you have then no flexibility in the questions you ask in the serving layer. You get to look up the keys that you've prepared. And then from there, you've got, well, I will just execute arbitrary SQL against my Postgres table. And,
and what could go wrong, right?
Like literally nothing except concurrency and latency. So in between, we've got all kinds of engineering decisions. And you're right, you do need to cook that data to get it prepared, but you still want some flexibility and interesting indexes potentially, right? And this is what I've been exploring is, what do you really want? What are the ways that you want to ask questions of those streams? So what is, Eric Sammer's position, Decodable's set of opinions? What's your perspective?
I think you nailed it, right? Like, look, in a perfect world, the cooking of the data is largely like in a perfect world that would be unnecessary. You'd be able to do whatever you wanted. Like in a perfect universe, you'd be able to do like whatever you wanted at runtime, at query time.
Because there are infinite computing and storage resources available in the serving layer. You can do whatever you want and it's instantaneous.
And so to your point, you can think about that as, okay, so like if that's the ideal state, assuming that it is, and again, like with reasonable data quality and those kinds of things, right? So like there's always like those kinds of things that you probably want to do. But like, and then at the other end of the spectrum, there's the optimized for a single use case, which might be like ad serving and optimization, like a behavioral vector, like a feature vector, or something like that, which might be at the very far other end of that. But again, like even that, is only going to be able to be optimized for a single use case. It's about specialization versus generalization. Right? And so I think what people are doing is that they're trying to get as close to the generalized case as possible so that they don't have to support multiple kinds of systems. So they can reduce like the operational overhead and the systems they need to support. Like if I needed 15 different databases to serve like one application, like at some point that becomes prohibitive, in terms of like overhead and stuff like that.
So at some point it becomes, resume altering.
Right. Exactly. At that point you hit bingo, right? And like you just win the database, you just win database bingo and like you're all set. But I mean, so I think that like that's not ideal. And I think what people are looking to do is figure out exactly where do they set the spectrum, where do they set the needle on that. And I think that, so I think if you have that single use case application, which I don't think anybody really does, or that use case drives so much revenue or so critical to the business that it makes sense to tweak for that. Ideally, you would want a more general system. And in that case, you're talking about just laying out the data and having the ability to change that structure of that data over time to be optimized for a set of use cases.
Yes.
And that's what I think the combination of a relatively flexible database system with some of the more advanced features beyond like just like a KV store, right? More sophisticated indexing. Not that you have any sort of opinion or bias about this, but like,
I mean, some,
which is okay. I think to have. I think your bias is right. But to have like, sophisticated indexes, long-term storage, support for aggregations, maybe even joins and like all of these other kinds of things that I think Pinot is a good example of a system that does this pretty well, and at scale while still getting sort of the latencies and stuff like that. And then you have like this other side of the coin. And I think stream processing is meant to complement that and be the Swiss Army knife to cook that data to whatever degree makes sense before it flows into that system.
Yes. And that is, I think we've laid out a set of engineering decisions and really economic decisions, same thing, a family of trade-offs between those two extremes because, you allowed, and I think we have to allow for the possibility of that key value serving layer. Like, hey, maybe there's a time that's what you need and it's appropriate to build that. And even though you're aware of real-time analytics databases like this time, no, we have to do this. I think we can grant that wise engineers might make that choice.
Right.
You're still sacrificing, you're going to get all the concurrency and all the latency, low latency, all the 1/over latency that you need. You're going to give up on freshness because you have to pre-compute and that's all fine.
Yeah.
But, so you do that. But that's unusual. That's kind of strange. And over here, you're with the more, as you say, supporting more use cases. Another way of looking at that is you're saying, I'm not going to make those decisions in the infrastructure layer. I'm going to be able to push those decisions out into the application layer.
Right.
So now I can construct a query and change my mind in the application about what I'm going to do. And we're allocating where the complexity goes. And this is a bunny trail we need not explore long. It just reminds me of Kafka. And Kafka's kind of decision to be dumb internally. It's stuck with that, and I think it's a very good decision because I've presented slides about Kafka and sort of intended software architecture, and the more tenured people in the audience have said, "Hey, that looks like an enterprise service bus. I've seen this. Yeah. I see you. I'm going to find you."
I have opinions.
Right. There are people who have been hurt, and that was justifiably, I have to validate that pain, but that was the opposite, where all the smarts were in the thing and not so much out here. And Kafka said, "Nope, this is going to be dumb. The smarts are in the consumer."
Right.
And we're saying kind of the same thing, that there's a point at which you want the application to be able to tell the serving layer what it needs, and make the serving layer smart enough to be able to react to that. But because we don't have computers that are made out of high-temperature superconductors with no parasitic reactances and infinite storage, we're not living in a Star Trek episode.
Right.
You don't get to do all that.
Yeah. I think, so again, like if you believe that you are probably not going to exist with a single database system or a single source system, like as either the source or the destination, but you also don't want 20, right, or 50, to power like a single application or a single service.
That gets back to that.
Right.
We want that small as possible.
Right. So, I mean, and again, like there's technical reasons, of course. There's also economic reasons and operational reasons and like all those other kinds of things. And so I think, at least the way I look at stream processing here is this is a system that can act as the right place to make decisions about what data is where, what shape it's in, and then give you the abstraction point, some of the intelligence that isn't built into like the broker layers and those kinds of things, which I agree, keeping that building block is actually very, simple is the right decision there, so that you can compose this in a way that makes sense for a particular application or system.
Yeah. And I want to flag something. We're talking about Kafka, and we're also talking about Decodable.
Yes.
There isn't
or
any,
I am.
You are. We have the founder of Decodable on the show. He's going to talk about Decodable. Kafka is kind of de facto standard and everything, but there isn't any necessary connection between the two. In the case of Decodable, your integration and stream processing on top of things what hold events.
Right.
And Kafka is one of those things.
Yeah. And I mean, for us, the way we think about the world is there's, the source side tends to be event streaming systems, Kafka, Redpanda, Kinesis, GCP PubSub, everything sort of in between. Operational database systems, OLTP system, Postgres, and those kinds of things for which we do change data capture and that as sort of the technique for integration. And maybe things like object storage and S3 and those kinds of things where we're sort of pulling files. And then on the sync side, it's all of those plus these real-time OLAP databases, which tend to be more on the destination side than the than the source side.
Yes.
At least in our world, they're the source and from the application developer's perspective, right? Like because they're querying that. System.
Right. From the application, it's where you're asking, but from the perspective of the data, it's a terminal node.
It's a terminal node in the graph.
You don't have Pinot queries go back and feed streams. I mean,
you could, but typically not.
It'd be weird. Yeah.
And then, of course, like the data lake, data warehouse systems also sort of come into play, which generally serve more of those. Or I think there's probably some overlap between those kinds of systems and the real time systems for sure. But like in the Venn diagram, there's like the set of workloads that are just like I need to store the last 500 years worth of click events, and I'm going to use that for offline model training or BI or something. Although, like I said, I think increasingly the real-time databases, I won't put words in your mouth, but I will say maybe those things in the Venn diagram overlap more over time.
There are always fuzzy boundaries in these choices. Right. I used to get the question, does KSQLDB compete with Postgres?
Right. Same deal.
Well, no. But, there are going to be these little things where, I have this table that I'm feeding with connect from a topic, and I only have one index that matters. Well, okay, that's a fuzzy boundary there.
Right.
And so I think you're right about business analysis is not the driver for real-time analytics.
Right.
Really. But I think in the margins, there will be interesting questions, and going forward into the future, as people are understanding that exposing the data of the enterprise to business analysts and decision makers was the thing that was cool 30 years ago, and the thing that is cool now is exposing that to users. Once that's established, then I think the notion of how one serves data and how long it ought to take and what we do with it, there's a shift there, and there's probably expansion into more traditional business.
Right.
We're 5 years from that, I think.
Right.
Databases, though.
Yes. Love them.
Aren't they great? Yes.
Love them.
Where would you be without them?
Where would you be without them?
Yeah, I also love them, and there's an interesting spectrum there. And I kind of started this idea of querying streams, and I kind of want to come back to that. And what do you think about that? Because we agreed that Pinot, just for the thing that I focus on, that's a terminal node.
Right.
The data goes there, and then applications ask it questions, and that's great, and it's engineered for that. And you kind of have to have something that's engineered for that for it to meet the non-functional requirements that exist there. And then there's Postgres, which everybody knows and loves, and it does things. And in between, there are the so-called streaming databases. I just mentioned there's been KSQLDB that Confluent has had.
Yeah.
There's Materialize, there's Rising Wave, there's Delta Streams, there's all these folks that we know who are solving this problem. What's going on in there? Because that's another one of these, there's a sliding set of trade-offs.
Yeah.
So how do you reason about that? When is it right to do one versus the other?
And I'll preface this with, I have a horse in this race, right? So
talk about your horse too, please.
Yeah. So, and I say that purely for full disclosure reasons, right? Because I think the context around this matters. So, my perspective on this is that very practically, stream processing and things like materialized view construction and maintenance and the actual query side of this, right, are effectively three components to the end-to-end flow there, right? And so like there's a group of people, and I'm probably in this camp, who believe that we will probably never build a better query, like storage and query layer, than a team of people dedicated to something like Apache Pinot.
Okay.
Right. And so our perspective is there's an entire team or company's worth of work, community's worth of work to be done there. And there's all sorts of different reasons why you might choose different storage engines for all the reasons that we're talking about before. Like sometimes KV Store, makes sense. Sometimes it's Pinot. Sometimes it's an OLTP system because you want to do in-database joins and like all these other kinds of things that like your dimension data is already there. And so you might, and like your fact table, for lack of a better definition, is small enough that what you actually need to be able to do is like join and then serve that data as part of a larger application. Like who knows? My position is like there's so many variations on that it's very difficult to imagine gluing those things together in one system versus allowing the customer to say, I can cook and prep this data in various ways and then send it to whichever system makes sense for our use case.
Okay.
Right. So I think that separation for me is sort of like keeping the smarts out of Kafka.
Okay.
It's about keeping the stream processing layer. And again, there's trade-offs, right? Like I want to be clear about that, but there, is about keeping the stream processing layer relatively simple compared to that plus all of the stuff that Pinot does, as a for instance, which is like a whole nother can of worms. And ultimately, what we see is that there's no one destination for this data. I think, like, to your point earlier, like, it's going into Pinot. It might also be powering various other things. And our sense is that if you try and cram that into one storage query, sort of, serving what I simply refer to as like serving, of that data.
Serving broadly and not my serving means key value store bias, but just where it goes for people to ask questions. Right,
exactly. To the application, like in sort of like whatever that is. I think that there's many different ways that needs to be done. And there are different scaling properties. Some of these systems are horizontally scalable. Some of them are vertically scalable. Some do both, right? There's there's services and API calls that need to get powered. It is the data integration method for a lot of external systems and those kinds of things as well, like writing data into an S3 bucket that, like, if you're a B2B company, like a customer then has access to, like, as a way of exposing, telemetry about, their account, like think audit log or something like that. Okay. So from our perspective, keeping those things separate has some pretty distinct advantages. And so, like, that's how I think about Flink versus like the streaming databases of the world. That isn't to say that I think that means that there's no good technology there. I mean, with all the love in the world to Pinot and StarTree, I think that there are use cases where, like, you want to use a Rising Wave or a Materialize or KSQL DB, whatever the case may be. And in that case, we would, like, internally at Decodable, we actually don't think of us being sort of competitive with these things. We think of them as also being terminal nodes.
Yeah.
Right. Yeah. That applications can then rest on.
Right.
But, like, there's other places that data goes.
Yeah. And see, intuitively, I think that's true too. That there is this streaming database niche in the world, and I don't know how big it is. And it feels like we're very much in an exploratory phase of that part of the stack right now.
I think so.
There's this flowering of companies solving the problem.
Right.
And
there's clearly a there. Right?
There's a there.
There's enough people there who think that that's the right way to do things. And like, look, from my point as a vendor, it does not matter what I think. Like, yes, I have a view of the world.
Fair enough.
What matters is what customers want to do.
Yes.
What, like, people watching this kind of show want to do with this data. And, like, I kind of look at that and go, like, do I really have a right to say, like, you're doing it wrong? Like, it's just like a bad look.
It's a bad look. Yeah. Your job is to serve them in the way with the things that you do.
Right.
Yeah.
Right.
I mean, we still have points of view. But
certainly have a vision for the world. You know,
yes.
if you will, a vision for the world.
Well,
Tim.
you know, that's here we are in the Bay Area. Recently moved to this, so I have to have a vision for the world.
Welcome.
I'm told I have to have a thesis. Do you have to have a thesis? Or
I think you have to have
VCs?
you have to have a thesis.
Okay.
You definitely have to have a rolling fund. You know, like
all right.
you know,
I have some puffy vests, so I think I'm okay there.
You have a Patagonia vest.
I have a good Patagonia outer shell. I don't think any of my vests is Patagonia.
All right,
and I'm from Colorado too. So that's kind of shameful for me.
You get a B plus.
Okay.
You get a Silicon Valley B plus.
I get some good Patagonia pants too.
Yeah.
That they have seen some action. I'll tell you what.
We'll let it slide.
So okay. I appreciate that.
Whatever just happened.
I'm learning to adapt to this new area. So the streaming database question and that middle ground, I'm trying to figure out, like, I know that is not a general purpose analytics solution, because generally your indexing flexibility is low, right? You tend to get kind of key value looking things.
Yeah.
And I'm just trying to nail down some parameters around. I mean, you're right that it matters what customers want, but also typically folks who listen or watch this show, they're like wondering, okay, well, how do I think about the architecture of this new world? And I'm trying to get some parameters around what are, you know, is that more for like kind of transactionally oriented queries? Like I want point queries of things. Can I use those to do a certain category of event at a time, real-time analytics computations? I'm just not sure.
I think, I mean, I'll be honest with you. Like, I think I could probably come up with cases where I think that makes sense. And maybe it's, you know, I don't know, some kind of like real-time matchmaking in gaming or something. I don't know. I could probably come up with like those kinds of things, or leaderboard, you know, surveying or something like that. Things that change frequently. And benefit from having the most recent, you know, the freshest data, you know, humanly possible there. You know, I also believe that you can do that with Postgres and those kinds of things. And like, it's a thing that you already have, or MySQL or Mongo or whatever. But I recognize that like there's some batteries included by having the processing integrated tightly with the serving layer. At the same time, I think the litmus test question for a customer is for a user of the, you know, if you're like building, you know, a platform and trying to figure out like when and where do I use these things, is like, does this data or a version of this data, a cut of this data, go to multiple places? If the answer is yes, I think you actually want a stream processing system, not a real-time database.
Yes.
And sorry, a streaming database. Because I recognize that like streaming database, real-time database, there's a little bit of like fuzziness for some people around those terms. When I say streaming database, I mean things that sort of natively do like the stream processing workload and like the materialized view calculation and those kinds of things. Again, like a rising wave or a materialize or a KSQL DB or something like that. And I think if the answer is no, my data is only ever going to this one place, then like there are operational advantages, quite frankly. Like I'll put in a pitch for those guys. Like, you know, I think there's an operational advantage to not running a separate system, right? Stream processing plus, you know, serving, you know, done. Yeah. You know, and especially if that fits on like one node, those things are like very efficient with like that single node style deployment and stuff like that. So, you know, on the other hand, I think like for a lot of people, you know, or at least, and again, selection bias, the people that I talk to, they're like, I've got Pinot, I've got S3, I've got some Snowflake, I've got some, you know, 87 microservices. And like they all, you know, I need to make API calls to Twilio to send SMS messages when certain events happen inside of my system or something like that. You kind of go like, okay, like, look, that is a stream processing engine, which we think is Apache Flink, that is doing that processing, creating those curated output streams, and like, and you know, and you should of course be using Decodable. You should be using Decodable, absolutely, 100%. And then sort of like connecting to those systems, and you know, some of them are append only, some of them understand like updates and deletes and those kinds of things. Pinot understands upsearch these days.
Yes, it does.
So like that stuff is super cool because we can emit like we do change data capture processing and then like flip bits in those records like in real time. And then you get the low latency query and like the query concurrency. So if you're serving any kind of like, again, I'll use the leaderboard thing because Diablo 4 just came out and I'm playing a lot of it.
Nice.
I shouldn't say that, but like I am. I'm playing a lot of it.
You need ways to decompress.
Right.
I frankly want to make more time in my life for
Founder
gaming.
therapy.
That is what I'm
Let me
talking
tell you.
about. Yeah.
But I think like being able to serve all those different use cases is, you know, that's the Swiss Army knife in my world. And to me, that's the difference between a streaming database and a stream processing platform.
There's more to explore here. There's more to talk about in the world of stream processing.
Next time.
There will be a next time.
Yeah, absolutely.
My guest today has been Eric Sammer. Eric, thanks for being a part of the Real-Time Analytics podcast.
Honestly, all jokes aside, thanks for having me. This is really great. It's always fun to hang out.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.